Welcome back, everybody. We're going to be on week 26, March 22nd to the 26th. And it's been a while since we've had a Skill Builder week. So put on your mathlete shirts and let's do Skill Builder week. But before we do that, it's time for our shout outs. And this week's bell is going to be our gong. We haven't had the gong for a long time. So here's our shout outs for all the folks that did over and above last week. Okay, so the first thing we always do is look for Mathia achievers. Now Mathia, we're introducing this new idea of special right triangles, the 30, 60, 90 triangle, and the 45, 45, 90 triangle. So I appreciate all those that reached out, logged into Mathia, and gave it a try. Each week it's going to make a little bit more sense. So last week we go to Alexis Brandt, Clay Contois, Gabe Giroux, Hunter Lawson, Colin McBride, Valen Magala, Quinn Moses, and Jackson Knoll. In period 5, Kristen Barnett, Carter Harris, Arthur Lucan, Matt McConnell, and Ashley Ohl. Thank you for what you've done on Mathia the last week. And now, in the classroom with hybrid learning, we have some people that go over and above to make our class discussions even better. And these are from Mr. Miller to you guys. Isabel Bennett, Courtney Brown, Nathan Bryan, Claire Darlin, Theo Gepetti, Gabe Giroux, Hunter Lawson, Valen Magala, Mikkel McLeod, Reliance Morgan, Jackson Knoll, Cam Odell, and Maya Westenskow. And then in period 5, Kristen Barnett, Spencer Deerdorf, McConnell, Kylie Heiner, Arthur Lucan, Carlene Nolan, Sarah Altman, Ashley Ohl, Jack Rookdy, Darius Waldo, and Teddy Weston. And those are our shout outs for last week. Now, Skill Builder week. It's been a couple months since we've done a Skill Builder week. So we got our mathlete shirt on and we've been equipped with this special right triangle. We've got our mailer that we sent home getting ready for SOHCAHTOA trigonometry. If you noticed, when we introduced the idea of these special right triangles, there were these square roots, radical 2. And then over here in the 30, 60, 90, there was the square root of 3, radical 3. So this week is our first opportunity in hybrid learning to have a foldable. So Mr. Miller is going to hand you a sheet of paper, okay, hamburger it, fold it in half, so that you have simplify radicals on the front, all right? Now when we simplify a radical, what does that mean? Can't we just plug it into a calculator and take the square root? Yes, but we want to be perfect. If you remember last week when we studied pi, pi was a number that went on and on and on and on forever. We don't want to approximate. If we approximate, engineers are going to have a tough time building those tall buildings, building those long bridges. We need to be perfect. And to be perfect, we need to be able to simplify, but continue the exact number of decimals. So here's an example. Let's look at the number 54. The number 54 can be broken into parts, okay? Now, one of the things we're going to do on our foldable this week is what's called factor trees, okay? Now, some of you may already know that 54 is nothing more than 9 times 6. And it's legal to write the square root of 9 times the square root of 6. And the square root of 9, remember your perfect squares. One of the things Mr. Miller is going to go over with you this week is the perfect squares. Take notes, refresh your memory if you've seen it before, and if you haven't, we need to know these skills. That's why it's Skill Builder Week. All right, so let's say you didn't know it was 9 times 6, okay? 54 is an even number. So we got a 2 and a 27. Okay, what are the factors of 27? We're trying to get the prime factorization. So we know 2, doesn't get any smaller than that. 27, 2 plus 7 is 9. There's a 3 in there, isn't there? 3 and a 9. So now we have 2 times 3 times 9. Some of you already know the square root of 9. The square root of 9 is 3. Okay, so now we can rewrite this as the square root of 6, square root of 9. We know the square root of 9 is 3. So this week, we want to focus on some skills with radical signs. Because if you take the square root of 54, 7 times 7 is 49, 8 times 8 is 64, somewhere between 7 and 8, right? That's not good enough for engineers. We need to be perfect. So let's practice Skillbuilder week, all right? Then in Mathia is focusing on what are the values of these special right triangles. We know that a 45, 45, 90 originally was a square. This length is the same as this length. So now we got some vocabulary here, don't we? We have the hypotenuse, okay? The side across from the 90 is called the hypotenuse. We've got to get some vocabulary in there. This length is the same as this length. We don't want to use the Pythagorean theorem anymore, so we multiply by radical 2 or divide by radical 2. And then taking a little bit more time is the 30, 60, 90. Remember we studied half an equilateral and the short leg, the long leg, and the hypotenuse. So we got some vocabulary, don't we? We got some vocabulary. We've got some skills, right? We're mathletes. Put on those mathletic shoes this week. Okay? Have some fun with radicals. All right? So, happy week 26. Yep, just around the corner is coming spring break. Let's hit our gong one more time. And hope that you have a great week, everybody.